Now let us discuss about one more important concept. It should be discussed while discussing the concept of lens or while we get into the topic of lenses. That is power of lens. I think most of the times you have heard of this word, which is a power. Because you saw many people wearing the spectacles, even me also wearing the spectacle. But when you ask about the spectacle, the people say this spectacle has some power. So they define their spectacle in terms of powers. Then what is the power of that spectacle? So it is a very important thing for the people, because different people have a different kinds of problem in the sights. They should wear different kinds of spectacles. I mean that spectacles should include different kinds of lenses which are having the different focal lengths as well as different radius curvatures. Then it can be determined all these things can be seen in only one word, which is power in terms of power. Then what is the power of a lens? So power of a lens means let me try to understand you in this way. People wear this spectacles to get the clear picture. So the different people have a different vision problems. Some people can see the distant one, and some people cannot see the nearest one. So for the people's requirement, they should wear different kinds of spectacles. So when they wear the spectacles, whatever the lenses which is fixed in that spectacle will try to converge or diverge the image onto their retina. We already know about our eye. Eye has a different parts, and eye will also have some lens, and after passing through that lens, it should fall on one surface which is in our eye. So if the ray is not properly converging, not properly falling on the region where it wanted to be fall, then we say that we have some eye problem. So to correct this, we wear the spectacles, and that different spectacle will converge or diverge the image in the required position. So that is known as the power of that spectacle. So power of spectacle means it is the ability of the spectacle or the lens to converge or diverge a ray of light falling on it. Okay. So in other words, what we can say is it is the measure of the convergence or divergence of light whichever falling on that lens. It is known as the power of a lens. Yes. So how to find this power of a lens? So in order to get a clear image, in order to see an object, the light from that object should fall on our eye lens, and it should fall on a different correct region. Then only we can see that image. So it should be, if it should be fall on the correct place, then we should wear a correct value of spectacle, which also having an exact value of power. So let us find the power of the lens. Now let us pass a ray of light. This is a ray of light, and in the path of this ray of light, let us introduce a lens. We are introducing a convex, double convex lens, biconvex or double convex lens. If you introduce like this, what will happen is ray will diffract. Ray will refract like this. See, this is the actual direction. So this ray is refracting to some angle, it is changing its direction. So by an angle delta. Okay. Without this lens, the ray has to pass in the, it has to move in this path. But after introducing this lens, it will change its direction with an angle of delta. Let's say this ray is coming from an object over here, and let's say height of this object is h, and this is a line at the this is a line at the center of this lens, which is called as an optic center. And let's say these are paraxial rays, means these rays are parallel to the principal axis. After refracting, it has to pass through the second focal point. So this is passing through the second focal point. So this is a focal point. So the distance is f. Okay. Now, if this is delta, then this angle also should be delta. Okay, it is from mathematics. So if this is delta, we know the values of h and f. We know the values of this side and this side. Then we can apply one trigonometry. We can take the trigonometry using the values of h and f. That is tan. Tan delta, this delta, tan delta is equal to opposite by adjacent. Opposite is h. H by f. If h is equal to 1, if it is h is equal to 1 meter, height is 1 meter, then what happens? 1 by f equal to tan delta. And this 1 by f can be written as capital P. So capital P means which is equal to 1 by f, which is also equal to tan delta. So P means it is called as a power of a lens. Power of a lens is inversely proportional to the focal length. As the focal length increases, power decreases. As the focal length decreases, as the focal length is shorter, then power increases. As the focal length is longer, power this will decreases. As a focal length shorter, power increases. As a focal length longer, power decreases. So this is the relation between power and focal length, and this power is also equal to tan of delta. So this is the equation to find the power of a lens. Then we can also define the power using this equation. That is, power is equal to tan delta. So power can be defined as, it is an angle by which ray of light is converged or diverged by a lens, which is falling at a unit distance from the optic center. So this is known as power of a lens. So let me write power of a lens. Lens is the angle by which it converges or diverges in beam of light is falling unit distance, is falling at unit distance from optic center, So this is known as power of lens. Now, for example, if the value of f is very short, if we designed one convex or concave lens which having a very less value of focal length is very short, then what happens? If the focal length is a shorter one which having a less value, then the power of that lens will be very high. So that high powered lens. Then the meaning is, if it is a convex lens, if the focal length of this convex lens is very shorter, then this lens has more power and this will converge more. If you consider double concave lens, focal length of this is shorter, this has high power, so that's why it will diverge more. Okay, this is one case. If f is longer, if the f has a high value, then this convex or concave lens has less power. Okay, so let's consider this very high value focal length, so that this has a less power, so it converges. There is a less convergence. Convergence is very less. If you consider a concave lens, then focal length is very large, and because focal length is very large, power is less power, and there is a less divergence. So this is the application, or yes, it is application of this power for these two lenses. So this is about concept of. Then, if you want more power of a lens, you want the lens which is having more power. If the lens is having more power, then it will converge more. So the concept of power is mainly used in the case of binoculars or microscopes, because object is too small. In case of microscopes, it has to enlarge it. So we need a more power of a lens. So to get a more power of a lens, what we have to do is we need to combine the 2 or 3 lenses. That's why it will have a lens which is having more power. And in the case of binocular also, you have to see a distant object and you should see it very clearly. Then what you have to do is you should have a combination of lenses to do this process. That's why those lenses will have a very high power. That's why to get a high power of lenses, we have to do the combination of the lenses. Unit of power is dioptry. This is the unit for power of a lens.